Alrighty. Okay. Find the prefix common array to arrays. Previously solved, medium. Okay. You're given two zero-index integer permutations a and b of length n. Integer permutations. They basically arrangements, right? The prefix of common array a and b is an array c such that ci is equal to the count of the numbers that are present at or before the index I of both a and b. Return the common prefix of a and b. What prefix of a prefix common array is array c such that ci is equal to the count of the numbers that are present at or before that index in both a and b. The count of the numbers that are present. Okay, let's go here. At I equals 0, no numbers in common. Let's see. So like 1 and 3, nothing's in common. And then at prefix 2, both 3 and 1 are in common. So it's 2. Prefix 3, it's 2. Prefix 4, prefix 3, it's 3. Prefix 4 is 4. So it's 0, 2, 3, 4. Okay. 2, so it's 0. 3 is in common, so it's 1. And then all 3 is in common, so it's 0, 1, 3. Okay. Okay. I think I just need to track the number of, I think I need to just track the number of items that are in A but not in B, and in B and not in A. Yeah, so maybe just track the difference frequency. Track the difference frequency. Okay, so let's say I have a common count. And this is going to be the common count. And then I'll just say n is the length of either A or B. I think I'll keep track of a singleton default dictionary for the frequencies. So I'll do frequencies, and this will be a default dictionary of hints where the key is the number in the array, and the value is the value at that key in the dictionary will be, I think it will be some sort of difference counter. Yeah, it'll be some sort of difference counter. So like it's positive, it's if it's in A, and it's negative, it's in B. Something like that. I could actually have two dictionaries here. So just have like stuff in A but not in B, and stuff in B not in A. Have two separate dictionaries for that, but I'll just keep it as positive and negative values in the dictionary. So how's this going to work? So for every index, let's say k in range n. I don't like using I as the index variable because it's hard to read. Every index k, let's say value 1 is nums at this k, and value 2 is nums, or nums a at k. Value 2 is b at k. I call it value a, value b. That's too somewhat ambiguous with a and b capital. So if it's already negative, then I'm doing a cancellation. So if frequencies of value 1 is less than 0, then this means that it's already there, and it's already a item in B, so that means I'm going to do count plus common increases by 1. I guess I do have the answer array as well. And then the answer array eventually at the end of this loop would do answer appends common. And after loop returns the answer array. And then frequencies of value 1 increments. I guess that's true for always true. That's always true. And then if frequencies of value 2 is greater than 0, common increases by 1, and then frequencies of value 2 decreases by 1. So like if I see a certain value, let's say 1 in the first array, that's going to increase because it's currently the frequency of value 1 is 0. So it's not going to say anything's in common, but it will increase the frequency of that thing by 1, so it'll be like positive 1. And then once it reaches something that causes the value to be seen in B, or B sees the frequency as positive currently, it will need to decrease it and say that that decrease is going to be an extra common. I think this works. Okay. Works all right. It's just very slow, it looks like, huh? Let's see if I can't figure out a faster way. Oh. Guaranteed to be permutation. Oh. I wonder. So here it does go up to n, and n is less than 50, so I could use just indices into an array instead of a dictionary. I think that's probably faster. So I'll go ahead and comment this out. Frequencies is going to just be 0 times n. Or I think it might need to be n plus 1. Because n can be a value inside the array. Okay. I think that works. Obviously indexing into a array versus a default dictionary is going to be faster, so it doesn't have to do the hashing. Okay, cool. Alright, so summary here. Gosh, this has been pretty easy. Yesterday was the hard one that was super quick. Anyways, summary. Basically find a way to keep track of the values that are unique to one or the other array. In above code used a single array where positive values indicate when the value actually is the permutation of n, isn't it? So I actually could have used true false. Actually no, right? Yeah. Positive value indicate when the value is has only been seen in A. Negative values indicate when the value has only been seen in B. When kind of deducting or changing value back to 0, that means that the value has appeared in the other array and is now common. So if it's negative and it's increasing because it's now appearing in A, then that means it's now common. If the frequency is positive and it's now decreasing because it's now appearing in B, then it is now something common. Yeah. All right. Time complexity, this can be O of n, where n is the length of the array. Since every position needs to be evaluated in both arrays. And then space complexity can be O of 1, since O of n, since we're tracking the frequency of every